Good morning, pilot teachers and students. Good morning, class. All right, thank you very much. You can sit down. All right, in our last lesson, we went through the topic of on symbols and understanding those symbols, or what are they used for. All right, you see that we defined each one of those. Now, in this lesson, our topic will be on electricity, and the subtopic will be electrons and current. Now, especially when we are going through electrons and currents, you'll be able to understand how electrons flow through a conductor and then into any of these appliances that we may use. All right, looking at electrons, probably if you can recall back to what we studied in the last lessons, especially you would know how in an atom there are small subparticles which are known as the protons, neutrons and electrons. So any conductor must always have a proton, neutron and electron, and they are free to move inside that. Now what happens is that when we are using a conductor, right, a conductor simply allows these electrons to flow through, right? An electron can sometimes be produced especially in a cell or battery or power supply, and these electrons are flowing through any conductor. And conductors, you should have seen that they are different types of conductors. One is a poor conductor, while the other one would be good conductor of electricity. That means it will have to allow this electricity to pass through. So a unit of electron is a coulomb. That is especially a charge on an electron, which is mentioned as a coulomb. So what we'll be going through now in this lesson is I will give you the notes based on these electrons and also the current. And there are some missing spaces that you will have to fill in with the correct word. So we'll go through quickly. This is the first slide. You can go through and then copy them down. And then after that, I will give you some time to work out what will be the words that you can fill in those missing spaces. All right, the first one, you can see that conductors contain many, okay? There is a blank space there. All right, just write the statement down. Allow some time for you to fill in that word, and then I will give you the next slide. Okay, everyone finish. I will not give it a second. And now on to the next information. Okay, looking at those three spaces in that sentence there, you can find that. And okay, you find number 5, blank space is a flow of electrons from the to the inner circuit. All right, you should have finished by now. I'll give you the next. All right, when there is a chemical reaction that takes place in a battery, it will be releasing energy which causes the, all right, you have something there to flow. And then you find a blank space, which is also question number 9. D on an electron is very small, and instead of using it as a unit of charge, a much more larger unit is used, or which is defined, called the, okay, that is for number 10. All right. Now on to the 11 and the 12. an electric current is measured using in a unit called placing those, and then you'll find that 1 ampere is the rate of flow of 1 coulomb of so that is 1 coulomb of charge that will pass a point in a circuit. Alright, quickly have this one done. I have something more explanation on the board. I will explain to you how it is taken. Alright, I will quickly go through the explanation of that, and then following that you can answer. Okay, there is also last one that you will have to copy. Right, for this one you'll find that, right, an ampere means that a coulomb has passed a point in a circuit in 1 second or per second. So that is why it is given as a current equals to the charge over the time. So you were given this, and then 1 ampere means that 1 coulomb has passed a point in a second in that second. So if it is 2 amps or 2 amps, it will be simply 2 coulombs has passed that point per second. So it is always like that. If it is 3, it is 3 coulombs. Or you can simply change it around and then say 2 coulombs equals to 2 amp second. Or if it is 3 or 1 coulomb, it is 1 amp second. Alright, there is the last one that I will have to give you. Right, looking at this one, probably you may have, when we're studying the charge of an electron, you should know how much 1 coulomb carries, how many electrons does it carry, from that equation written below. The last and the final one, right, the smaller units of current can be milliampere and also microampere. So that is how you can, those are the units, smaller units of current. You can use those units to measure electric current. All right, since you have copied those information down, I'd like you to go through in proofs quickly. For the pilot students, your teacher would now ask you to go through and then fill in those blank spaces which are given from those sentences. So what you can do is quickly go into groups, right? Discuss among yourself on what you will fill in those blank spaces, and then we will go through that towards the end of the lesson. And that means we will have to, or I will have to give you some time to quickly go through and then discuss your answers to those blank spaces. You can do that now. Okay. 1, 2. Yeah, 13 question 1, 2. 2s will do question. You will do question 1 and 2. 1 and 2. Let me see. 3 and 4. Okay, you give answer to 3, 4. 1, 2, 3, 4. 5 and 6. 5. Question 5. 5. 6 is yours. 7, 8. Okay. 9 and 10. Okay. 9, 10. 11 and 12. Let me see. You last question 13. What did I say? I forgot what.
Did you just come here and say it?
Yeah. What was yours? 12. So sit to me 11. Huh?
You just say the words.
Right, you can say the words. Just stand up and then say, okay, what words should come in there.
Just say one word.
Yeah. So after that, you pass mic to him. That's 1 and 2. All right, we will now go through the questions. Okay, those missing words, those students who have been chosen. While a teacher, you can also ask the students to come up with words to those missing spaces. All right, we started with question 1. Okay, the words for question number 1 will be electrons. So conductors mainly have electrons which are free to move. Okay, that is especially for a conductor. When a conductor is connected to a battery cell or power supply, these electrons will. All right, moving on to the second one. The second question, that missing space for 2, 3, and 4.
Charged.
Charged electrons. Any other words that may come in there? All right, it is simply, okay, you can have it as charged electron, but this time probably we have it as free electrons, okay, move in a particular direction, which is from the
negative.
okay,
Negative
from
terminal.
the negative to the
Positive.
positive. All right, so looking at this from that explanation, you will find that here on the board I have a diagram that shows you, especially for the electrons. All right, when there is a chemical reaction that takes place in a, let's say, a very simple cell. All right, you know how it is done. All right, these ones are the okay, you have these which are known as the electrodes, and in here you have the solution which is the okay right. What happens is that there is a reaction between these electrolyte and also the electrodes. So when this happens, the ions are formed. Okay, so there is a flow of ion, especially the negative ones will be attracted towards the positive. So when you have a conductor, then it allows these electrons to move. So you simply find that they move this way from the negative to the positive. All right, we'll go on to the, so number 2 will be free electrons. Third will be negative 2, 4, which is positive. All right, we'll move on to question number 5, 6, and 7. Okay, who's the 6? 5. Pass it to Mark.
An electric current is the flow of electrons.
Okay, number 5, good. An electric current is the flow of electrons. Okay, number 6. Number 6. Positive, all right, good. Positive should come in number 6. Number 7.
Negative.
Okay, good. So number 7, number 6 and number 7, this one should be an electric current, and then you have this which is positive, and that is, okay, good, negative. So in here, looking at this diagram here, you find that the electrons will be flowing in the opposite direction to the current. So this is where the current has to flow, while the electrons flow in the opposite direction. Okay. Right, moving on to question number 8. Okay, 8, 9, and 10.
Electrons. Electrons.
Okay, good. Number 8 will be electrons. Number 9.
Charge.
Okay, good. So number 9 should be the charge on an electron. It's very small, and instead of using it as a unit of charge, a much more larger unit is defined called the
Coulomb.
right, coulomb. Okay, coulomb is number 10. Right, good. Now we'll move on to make corrections to those quickly. Okay, now to the next, that is number 11 and 12.
The answer is an ammeter.
Okay, electric current is measured using an ammeter, and it is okay in a unit called the
Ampere.
ampere. Okay, amps or ampere, that is the unit of current. And for the last one, our last question, okay, that is for Michelle.
One coulomb is the charge carried by 6.25 times 10 to the power of 18 electrons.
Right, excellent. So you have 6.28 times 10 to the 18 electrons. That is for number 13. Okay, so from this we can write this equation as current equals to charge over the time. And it is given on the board here as current, which is 1A, which is equal to 1 coulomb per second, meaning that, quiet, right, meaning that, okay, a coulomb of charge has passed a point in a second, or second in 1 second. And you can either change that equation to give you 1 coulomb equals to 1 amp second. So that is all about current and also the electrons. Now, when you were going through and then looking at or studying chemistry, you should have known how this is produced, especially in a dry cell. The batteries, you will find that there is a hard core which has carbon electrode, and from this you have the positive and the negative. And you have the paste or something like that which forms an electrolyte, and that is a solution or paste, not a solution, but it is a paste which is known as a manganese paste. So looking at this, and that is where the reaction has to happen with the carbon electron, and then electrons flow from that. But in a lead accumulator, rather the accumulator, that is especially for the car batteries, there is a reaction going on, but each time when this reaction is going on, the lead is accumulated, meaning that you can use it, or you can use the acid to producing electricity again. So that is especially for those lead accumulators. And example of that is the car batteries. So in general, you should have seen how the electrons are flowing, especially in a conductor. When you connect that to a dry cell or battery or even a power supply, what happens is that these electrons must flow. And because these conductors are made of, or they have something like free electrons, it easily allows these electrons to flow from one point to the next, especially in those supply. And looking at the current and also the electrons, the current will be basically going from the positive towards the negative, while the electrons will be from the negative to the positive. Right? They flow in opposite directions. And looking at that, because a coulomb is a larger unit or smaller unit, they have to use a much more larger unit, and that is simply 6.25 electrons make up one coulomb of charge. And you can see that it is almost about 1.9 times 10 to the minus 19 coulombs. Okay. So it is about 1.9 times 10 to the minus 19 coulombs. Right, so that brings us to the end of our discussion on current and electrons. In our next lesson, we'll be going through and then looking at voltage and current. Right, do you have any questions? Any questions? All right, if there are no questions, our keyword for today will be all right, our keyword for today will be electrons and current. Okay. Once again, good morning, pilot teachers and students. Good morning, class. All right, thank you. You may sit down.